Hello, everyone. In today's lesson, which is our first class today, we'll be talking about indices from the scratch. But today's lesson will be focused just on the introduction to indices, the basic things you need to know about indices. So whenever you hear indices, I want you to understand and see indices as simply the plural of the word index. Okay, index means raised to a power. That is what index means. So that's why I'm saying here that indices simply means exponents. The number, that small numbers that tells us how many times a number is multiplied by itself. For example, now if you have, let's say you have 2 to the power of 3. This is the same thing as saying 2 index 3, right? That's where indices comes in. So this is telling us that 2 is multiplying itself 3 times. And of course, this will give us 8, right? And that is what indices is all about. Tells us the number of times a number multiplies itself. So there are numerous laws guiding the study of indices. And of course, if you are not familiar with these laws, it will be difficult for you to solve certain problem from indices. Okay, so let us go through these laws briefly. The first law, which is called the multiplication law, tells us that whenever you are multiplying two terms of the same basis, what it implies is that you simply add the powers. Remember, provided that the bases are the same thing. So this is the base A, while this is the power, right? This is another base, and this is the power. And the bases are the same thing, being A and A. So what you do here simply is just to add the powers. So you call it A raised to the power of M plus what? N. That is what it is. Supposing you have 2 power 3 multiplied by 2 power 1. What it simply means is to call it 2 to the power of 3 plus what? 1. You add the powers because the bases are 2. The bases are the same thing. And that will give us 2 to the power of what? 4. Okay, that is what this law is all about. So now let's go to the second law, which is division law. This should be division. So if you have A to the power of M divided by A to the power of N, notice that the bases are the same thing. The basis, when you have something like this is the index, while this one here is the word base. So whenever you find out that the bases are the same thing, what you simply do is just to subtract the powers if it is division. So this is division, we call it A to the power of M minus N. So if I have 2 to the power of 4 divided by 2 to the power of 2, for instance, I will just call it 2 to the power of 4 minus 2 because the bases are the same thing, and that is 2 to the power of what? 2. And that's just it. Easy, right? Let's get to the next law. The next law says if you have, this is power multiplying a power law. So A to the power of M raised to another power of N. This simply means A to the power of M multiplied by N, just times the powers if you see something like this. Which means if I have 4 to the power of 2, then raised to the power of 3. This is simply 4 to the power of 2 multiplied by 3. And 2 multiplied by 3 will give us 6. So this is just 4 to the power of what? 6. The next law says A power 0. Any number or letter raised to a power of 0 is simply 1. Please. Okay? Even if you have 4 power 0, 3 power 0, that will definitely give you 1. Don't forget to master all these laws because these laws will help you in so many ways in solving different equations that will come up in indices. This is just a fundamental class in indices that will help you and guide you to deal with every problem you might encounter in your study of indices. Now, when you have a fraction and they have a common power, what it means is that the power will be shared. This is A power M all over B to the power of what? M. This implies that if I have 2 over 3 raised to the power of 4, I can call it 2 power 4 all over 3 to the power of 4. They will share the same powers. And 2 power 4 is 16, while 3 power 4 should be around 81. That's the implication. Now, whenever the power of a number or a letter is half, it simply means the square root of that value. So this is a square root of what? A. So if I have 4 to the power of half, the equation is indirectly asking me to find the square root of what? 4. And the square root of 4 is just what? 2. Good. Now, in the next law, we have we are having a to the power of negative m. Now, when the power is negative, just call it 1 over a power m. Okay, supposing you have 2 power negative 3, that would be 1 all over 2 to the power of what? 3, and that's just it. And when the power is a fraction like x over y here, what it means is that y becomes the root. The denominator is the root. That becomes the white root of a, then to the power of what? X. That means, for instance, if I'm given this problem to solve, 8 raised to the power of 2 over 3, and I want to simplify this. So what this will mean is cube root, the denominator comes as a root, then 8 raised to the power of the 2. Okay, now this is the same thing as the cube root of 8 can be broken down as 2 times 2 times 2, because 2 times 2 is 4 and 4 times 2 is what? 8. So I can represent 8 with 2 to the power of 3, then everything to the power of 2. Good enough. This is cube root and this is a power of 3. So this power of 3 cancels the cube root, leaving us behind with just 2 to the power of 2. And 2 to the power of 2 is the same thing as what? 4. So this is just it on our introductory class on indices. I just took my time to give you the meaning of indices and the rules guiding indices. In our subsequent classes, we'll be exploring so many angles in which equations can come from indices. So for now, let us entertain some questions. Bye.